Good morning and welcome to this quantum computing session. We're just going to let people join the session and we will start in 30 seconds or so. So thank you for joining us. Bear with us for a moment and we will speak to you very shortly. Okay, so people are just joining there now. Okay, so I think we will start. So again, good morning and welcome to this session on quantum computing. Thanks very much for joining us at this early hour. Our session this morning is entitled Quantum Computing, Advancing Enterprises and Career Paths. This is really about the opportunity in quantum computing and what Ireland needs to do to be able to take advantage of it. I'm going to do a quick screen share of our agenda this morning. So hopefully you can see my screen there. So my name is Paul Hearns and I'll be your moderator this morning. So we're going to start with a quick address from the Quantum Computing Industry Advisory Board Chair, and that's Anthony McCauley of ICT Skillnet. Then we're going to have Maeve Corcoran from Accenture Labs, and she's going to talk about the industry applications and developments in quantum computing. Then we're going to have Kieran Fennessy from Citi, and he will give us a financial services view as one of the key areas where quantum computing is being worked on and is likely to see major adoption. Then we will have Venkatesh Kannan from the Irish Centre for High-End Computing, and he's going to talk about skills development, training and talent development, and specifically the quantum computing training programs that are being developed and will be delivered in the coming months. Then we're going to have a word from Steve Flinter, who is Vice President of Artificial Intelligence and Machine Learning with Mastercard Labs, just a little bit more about the Industry Advisory Board and some of the activities there. Then we're going to have a panel session and Q&A. So as you look at your screen at the bottom, you'll see a Q&A function and you'll also see a chat. While you're free to put questions in throughout as the speakers present, we'll try and deal with questions in the Q&A unless the speaker wants to deal with something specifically as they go. However, if you want to add a comment, an experience or an insight, or perhaps share a resource, please do use the chat function for that. So please try and separate Q&A and chat, and we'll address as many as possible and give people the opportunity to take advantage of all of the expertise that's here. So the panel session will also be joined by Anthony McCauley and Peter Woods, Public Sector Liaison and Business Development Manager at ICHEC as well. So we'll have quite a range of expertise there. So I draw your attention to the IAB members at the bottom there. That's a current list. And just to acknowledge the help and support that the members provide there. And just to remind you that other information will be available on ictskillnet.ie. So back to our panel of speakers then this morning. I'd just like to invite Anthony McCauley, IAB Chair, to say a few words. Anthony.
Thank you, Paul, and good morning, everyone. As Paul said, I'm Anthony McCauley, and I'm the chair of the advisory board. Today's webinar will introduce you to new skills pathways designed to meet the needs of organizations wishing to equip themselves to address the market potential of quantum computing. These pathways they're designed to build talent, the talent required to place Ireland as a leader in a fast developing technology, one which quite recently state agencies such as IDA Ireland now believes are at a tipping point for commercial development. The pathways presented today offer a unique opportunity to place Ireland at the forefront of growth in sectors such as financial services, manufacturing, pharma and technology service, among others. ICHEC, in partnership with Technology Ireland ICT Skillnet, will introduce these pathways in 2022, starting with first two pathways to meet the requirements of executives and technology managers, and then with another one for developers, which is currently under development, so to speak. We intend for the executive and the technical manager pathways to provide leaders with the insights required to make decisions, to be able to ask the right questions, to grow talent, and then for the developer pathways to target the creation of solutions. As Paul said, our webinar today will take three parts. Venkatesh will introduce the pathways themselves. Maeve will put these solutions in a commercial context to show the potential for the solutions. And Kieran will then explain why Ireland has the track record for Ireland to achieve success in quantum. Finally, I would like to thank the members of the Industry Advisory Board for helping to design these pathways. It's taken a significant amount of time. It's about 18 months in development. ICHEC for creating the modules and making them real. And finally, Technology Ireland ICT Skillnet for bringing these pathways to market, providing Ireland with a first mover status for quantum computing, potentially on a global basis. We hope that you enjoyed the webinar this morning. We hope that you enjoyed the panel discussion. And Paul, I'll give it back to you to get us underway.
Thank you very much, Anthony. And again, our theme this morning is really around the fact that quantum computing is predicted to be not just disruptive, but a genuine leap forward, and possibly the greatest leap forward in recent time in computing capability. And consequently, it requires new means of engagement and usage, and also a different approach to skills development. However, as Anthony pointed out, Ireland is well placed to take advantage of this. So we're just a little bit of housekeeping and format as well. This session is being recorded for later playback, but also we have a couple of polls this morning which will help us and the advisory board to steer things as well. So I'm just going to ask our producer Sarah to put up the first of those polls now, and we'll get you to respond to those if you can while we're going through our next section. So we'll move straight along then to our first presenter this morning. Maeve Corcoran is Managing Director of Accenture Labs in Ireland, and where she incubates and prototypes new concepts through applied R&D projects that are expected to have significant strategic impact on Accenture, its clients and society. She focuses on responsible AI and specifically helping organizations address the challenges of algorithmic fairness. She is globally responsible for AI lead for technology and innovation. She also works in the area of quantum computing for Accenture Labs, and specifically in quantum chemistry in collaboration with academia. So Maeve, welcome.
Thank you very much, Paul. Let me just share my screen. I just have to get it up into full screen here. 1 second. Paul, you could tell me maybe, is that now full screen?
That's full screen now.
Okay,
that's good to me.
Perfect. Okay, great. Okay, so thanks very much for the nice introduction. So I am going to talk to you today about getting ready for the quantum impact. So initially, I'll just talk a bit about what we're seeing in the market and what the market's saying in terms of the scale of growth over the next few years. Then I'll be talking to, from an industry point of view, what quantum is good at and where we're seeing and we think it'll impact industry use cases and get to value over the next number of years. And then finally, I'll close out with, from our experience in the market, what we think industry needs to do to take advantage of quantum and the value it will bring, and how the course Venkatesh, who I'll be talking to, can help with that. So let me see. Okay, so first of all, what's the market saying? So, I mean, if you Google out there the growth of quantum, like there's so many surveys or outcome is saying how much the quantum market will grow. This is one from Triadica in 2019, saying they expect to grow to 9 billion by 2030. We're seeing actually huge growth in the market. So, for example, in the quantum computing as a service market, in all of 2020, I think the capital flows through was 1 billion, and in the first 6 months of 2021, it was 2 billion. So it really, we're really seeing traction across the board in terms of enterprises looking to start trying it out and do different things with it. And then also, there's a survey here from IDC, which actually goes straight to the horse's mouth, if you like, and asks industry participants what they expect to be doing in quantum. And 65% of the industry participants said they expected to use cloud-based quantum computing by 2022 or by next year. So it really, really is becoming widespread. It feels a bit like us what AI felt like sort of 5 to 7 years ago. A lot of people, a lot of enterprises really starting to see the value now and really starting to look to see, okay, how can I leverage it? How can we get to value? I think one thing that's slightly different from AI was if you had an analytics team, it was quite easy to sort of incrementally, get somebody on the team, just one person to try a POC, whereas quantum, a little bit more is needed in terms of getting an enterprise ready to really take advantage of quantum. But another interesting thing from the point of view of quantum is that actually, so obviously quantum computers and in the cloud are available now, and it's almost like the race will start in 5 years' time, but everybody has loads of time to train and get good at it before the quantum computers that really are that really can bring commercial value will be ready, compared to AI, where it was more. I mean, what we're seeing is, AI came fast, but we think that when quantum computers get to scale, the speed at which value will be created will make what happened with AI look like a snail's pace. But I think one thing to keep in mind about quantum computers quantum computing is that it's very good at certain tasks. So we don't expect it to take over every task that classical computers do today. There's very specific tasks and use cases that quantum will be very good at. Next slide. And timing. Okay, I'll speed up a bit. So in terms of the types of problems that quantum computing can solve are really very complex, usually statistical problems that classical computers just aren't powerful enough to handle at the moment. And really that's down to, and I'm not going to get into all of the tech, but really two things. It's I don't know if you're seeing that on my screen. It is basically using superposition. So the fact that qubits, which make up a quantum computer, versus bits in a classical computer, can hold different states at the same time, and then also entanglement, which means these qubits, when they're entangled, an action on one qubit impacts the qubit it's entangled with, no matter how far away it is. So those two properties of quantum computing and qubits together mean that quantum computing can look at multiple variables at the same time and multiple inputs, compared to classical computing, which is more a one at a time sort of thing. So that's why quantum computing can really make a difference in these complex statistical problems. So we've seen 4 areas where we see quantum computing really having an ability above classical and really make an impact in terms of use cases. The first one is in terms of prime factorization. So quantum computers, when they're strong enough, will be able to actually factor any huge numbers into their primes, which is the basis of RSA. A lot of public key encryption today, basically most email and websites use that type of encryption, And once quantum computers are strong enough, which people are saying between 5 and 10 years, actually they'll be able to break those public keys very easily. So there's a lot of work going on today in the States. NIST is a standards body which is looking for these post-quantum cryptography algorithms that will work. So that's an area which is coming, and actually it's interesting in terms of any company that has IP or trade secrets today that they'll need to be using in 5 or 10 years and keep secret for 5 or 10 years. It's really important that they get assessed, because there's a danger that there's bad actors today saving those down if they're transported across the internet today with current cryptography, and they will be able to decrypt them in 5 or 10 years time when the quantum computers are strong enough. So that's one area. A second area is sampling and simulation, and this is specifically simulation molecules. So this is really important in life sciences and chemistry, chemical industries. And basically why quantum is good at that is because simulating molecules, the internal workings of a molecule and the interaction between the atoms is effectively a quantum system. So where classical computers, the maximum they can do today is say a molecule with dozens of atoms in it. Things like enzymes, which are very important in life sciences, say for creating new drugs, have thousands of atoms. So you need a quantum computer to be able to simulate them. And what happens today is they actually, in those industries, they have to physically create the molecules and do physical experiments, which takes a long time. And that's one of the reasons why drug development takes so long. So that's an area where we expect a lot of impact. Optimization is another area where quantum computing is really differentiating. And again, this is because it can look at multiple variables at the same time in multiple inputs. So things like the traveling salesman problem, like how to deliver packages, logistics scheduling will be transformed when we have quantum computers strong enough to be able to do this. At the moment, what happens is either a lot of approximations are done, which leads to a not very accurate answer, or it's just not possible at all. And what we're actually starting to see is, in some situations, quantum computing will be used if there's a very large search space to actually narrow it down initially to a smaller search space with a high level of probability, and then classical computing to be applied to that smaller search space to narrow down to the specific answer. And then finally, machine learning algorithms. So quantum algorithms, so there's so much data available today, and it's always growing. And really, machine learning is about looking at all of the data out there and actually basically learning the behaviors and the important factors. And classical computing is very quickly coming to the limit of what machine learning can do in terms of those huge data sets. So these new quantum AI algorithms are able to work much faster in a parallel manner to actually leverage these huge data sets and sort of make sense of them, if you like, from a machine learning point of view. Okay, so then in terms of some examples of Paul, let me know as well. Maybe you could give me tell me when I have 2 or 3 minutes left. In terms of where we're seeing it already, I mean, there's these companies like Amgen and Biogen. Actually, we've worked with them in the molecular simulation space in drug discovery. So they're pushing ahead there. Financial services, we're seeing a lot of traction there. Kieran's going to talk to it. Actually, this is one of the first places that we think that we are going to get to commercial value from a quantum point of view in financial services. In products, VW has used the optimization side of quantum to actually optimize routes for buses, and they're the first in the world to show that. Daimler is using the molecular simulation side of things to actually improve electric batteries for their electric cars, and sort of the list goes on. So this is just a sample, but but I guess it's just to show that there's a lot of companies out there already starting to use quantum and to see where it can bring them value. And then just in terms of what we're seeing at the moment globally is, and again, it goes back to, it's sort of similar to AI 5 to 7 years ago, a lot of, bottom-up funding. Somebody has a side interest in quantum. They manage to get a little bit of funding to try a POC. I mean, all of this is interesting, but it doesn't actually lead to outputs really that scale. It's more like an exploration leading to some proof of concepts and maybe research papers. So what we recommend is actually a much more strategic, business-centered view of how to look at quantum and how it might impact your business with top-down funding. So understanding from the top of the organization the requirements, having business quantum leads, not just IT knowing about it, ideas and innovation that lead directly to business value. So having business value lens on all the time when we're looking at quantum. And by doing this and integrating into the enterprise infrastructure, we're seeing companies that are preparing to be able to innovate at speed and scale once those larger quantum computers are available. And I suppose the 4 key steps that we see in terms of accelerating an enterprise's journey to get value from quantum, they're listed here on the screen. Learning what quantum can do for your business, building a strategic roadmap. Number 3, in terms of evaluating the hardware and the software, that's something that's slightly different than AI, in terms of you need specific hardware and software for quantum. So that's something that's sort of a new piece, if you like, and then source or develop quantum talent. And I think Venkatesh is going to be talking to you about the 3 different options for certification, and the technology manager option actually should prepare a company very well to be able to start on the path and to progress in these 4 steps. And then in terms of sourcing and developing talent, I mean, these, I won't go through the slide in detail because I think I'm over here, but these are the sort of skills that you need. So a balance of more academic, technical, and then more development applied. And you can do that. You can build these on your own, or you can sort of work with a quantum provider or a quantum innovation partner, sort of supplement your resources, maybe while you're building skills. And I think what we think from the four key steps when you're building up your quantum skill base in your company or your enterprise is make sure you look to build a multidisciplinary team. You need the developers, you need the scientists, but you also need industry experts and delivery leads. We saw this with AI sometimes, where companies would hire in a couple of PhDs, AI PhDs, and think, okay, we're going to have AI at scale across the company. You need the mix, the multidisciplinary team. You need to, know the blind spots. Basically, certain skill sets are more keen on certain things. You need to make sure you're covering everything. A flexible talent plan, like I was just mentioning, you can use external talent as you're building it up internally. And then I think number 4, investing in an industry relevant quantum training program is key. And again, Venkatesh will be bringing you through, but the more detailed program that's in the works, for developers, it would be, would definitely tick the box on number 4 there. Okay, so that is my talk. Sorry, I went slightly over. Paul, back to you.
Thank you very much, and that's no problem. That's given us a very good overview there. So moving swiftly along, Kieran Fennessy, Program Manager with Citi, is going to give us a little bit in terms of the financial industry, but more specifically why Ireland is best placed to take advantage of the quantum computing revolution, I suppose is a reasonable word. So Kieran, great. If you want to take over.
Yeah, thanks very much, Paul. Thanks ICT Skillnet for having this session. Sarah, if you wouldn't mind sharing the slides, please. Oops, up to the start. Great, thanks. Right, so we'll move on to the first slide. Thanks, Sarah. So really, when you think about it, when you take a step back, obviously quantum computing comes from quantum physics, quantum mechanics. And there's been a long history all through the ages of physics and finance combining and working together. If you think back even to the early first decade of the 1900s, Einstein came up with his Brownian motion and Brownian movement and his theory around that. That has been adapted into stocks and stock models and stock cycles, all the way up through the 70s and 80s, where the Black-Scholes model had a strong physics dependency, and there's some research out there that shows the correlation of it to quantum mechanical systems. And then obviously through the 80s and 90s and today with quantum computing, there has always been that close link between the area of physics and its application to the wider financial services. So if we move to the next slide, please. So this is an interesting research paper by McKinsey on how quantum computing can change financial services. And it obviously resonates a lot with what Maeve was talking about on her slide, right? When you think around financial institutions, right, you're thinking of how they can apply quantum computing. You're looking at very, very large unstructured data sets, right? But you're also thinking of complex parameters that feed into them, and a very, very quick decision is required. That's the kind of three kernels. They're the essence of how financial services will be applying quantum computing. So they can be in the capital markets, corporate management, portfolio. Maeve mentioned around encryption related activities, around cryptography. So it's those algorithms and communications that either from a communications perspective need to be encrypted. We'll see that in a few slides time, but also the algorithms, large data, really, really quick answers needed. So that's kind of the essence of where it's coming from in financial services. So the next couple of slides then we'll look at use cases and how they're being applied by various organizations. So in the next slide then, we talk around, I think if you want to move to the next slide, please. So this is City, where I worked last year, highlighted as one of the 5 emerging tech trends to watch, right? And again, we're looking at improving trading algorithms, reducing fraud, optimizing portfolio, and managing risk. Again, when you look at these kind of areas of focus, what are you looking at? You're looking at algorithms, which is large number crunching across large data sets. Again, we're going back to the large data that can be done really quickly on quantum computing. Reducing fraud, huge aspect of fraud, not only from an encryption perspective, but analyzing the high volumes of fraudulent data that can be fed back. Again, goes back to your machine learning that Maeve mentioned. Optimizing your portfolios, quick decisions, unstructured data, what can be turned around quickly, and likewise with risk. So that's kind of Citi's view. And then in the next slide, we look at JP Morgan and some research they did on their option pricing using quantum computers. And what they realized was they did Monte Carlo analysis. And with a quantum computer algorithm, the performance of it was a quadratic speed up. So what's a quadratic speed up? Essentially, it doesn't mention it in the paper, but if you take that there on a classical computer, their Monte Carlo analysis ran in 1 million hours, we'll say, right? Quadratic is the square root of that, which is essentially 1,000. So depending on the size of your performance, which are classical computer, your quantum computer is the square root of that speed up. That's for industry, for looking for quick decisions, looking across large volumes of data, or the risk models here, Monte Carlo analysis. That's really, really key, and that's really critical. And then in the next slide, thanks, Susan, we have Goldman Sachs. Again, what are we looking at here? Algorithms, complex calculations, speed. So that's the common theme that we're seeing across financial services, is those categorizations. So where, in the next slide then, please, where does that leave us? So quantum computing and programming, I think this is a fantastic opportunity, right? It really pushes Ireland out there between Technology Ireland Skillnet and ICHEC combining on their quantum programming for Ireland. The 3 courses that are out there, the executive, the lead, and the developer, really puts Ireland at the vanguard of this. I think Anthony mentioned that to start. Like, this is really pushing it out there. I'm not aware of any other countries that are promoting it or offering these type of opportunities. for the corporates working in them. But in the next slide, we'll see Ireland has a bit of a history of first, right? So little side note, a little bear bug of mine, Ireland doesn't really do a great job of recognizing our kind of scientists and the role they played. So William Rowan Hamilton was born in Dominic Street off the top of O'Connell Street, right? He was a professor of maths and astronomy in Trinity, and he was based out in the Dunsink Observatory, which, if anyone knows, is just there where the southbound M50 and Blanchardstown exit. It's in there on your left, right? It can actually, they have open lights. But what Hamilton did in 1827 was he defined or derived the Hamiltonian function, right? The Hamiltonian equation, right? That describes that established the wave theory of light. So Hamilton is often considered as the grandfather of quantum physics, because quantum physics came around in the 1920s. 100 years beforehand, Hamilton had defined this equation. And it was this equation then that was taken further by Schrödinger. And Schrödinger took it further in defining his Schrödinger equation, which then led to the whole idea of Schrödinger cat, which is when the cat is in a box. If anyone doesn't know, there's this thought experiment he created where a cat is in a box and there's a radioactive substance there. But you don't know, at a certain time, the radioactive will start to decay, but you don't know until you open the box whether the cat is alive or dead. And that goes back to the whole superposition theory that Maeve mentioned, which drives your quantum bits, your qubits. You're either 1 or 0 or anywhere in between, which gives quantum computing its processing power. So really there's a traceability from where we are with quantum computing now in the 2020s, going back to literally 200 years previous to the work that Hamilton did. So if we take it forward then, another unknown, I think, Irish scientific legend, for want of a better word, is John Stuart Bell, who was based in Queen's University in Belfast. So what happened in the 1930s and 40s was the idea of quantum entanglement, as again, kind of what Maeve mentioned. This is where two quantum particles, once they're coupled together in a quantum pair, they can spread out to any distance. We're talking across galaxies. And they will still, if one spins one way, the other will spin the same way. The momentum will be the same. They're paired over great distances. Now, Einstein disagreed with this, and Einstein actually called it spookiness at a distance. And in 1964, John Bell came up and proved that Einstein was in fact wrong, and quantum entanglement could actually be proven. And to my knowledge, I don't think there's any other Irishmen out there, men or women, that prove Einstein wrong. But this quantum entanglement, if we move to the next slide, please, is actually what's driving the quantum communication. And there is and within the course, there is a module on quantum communication. And what you find with quantum entanglement is it drives the security between messages. So now when messages are exchanged, there is an ability to hack them. But once you use quantum entanglement, they are encrypted using the powers of and the laws of quantum physics. So what the Chinese have proved is in 2016, and this is an interesting article in the New York Times if anyone's interested in it, is that they were able to prove quantum encryption around a secure key between two stations 700 miles apart. This is actually using the work that John Bell did in Belfast. So then just moving on to the final slide, I thought this might be interesting. This is a bit dated, but I still think it just shows a geopolitical lens almost through it, where you see a lot of the quantum communication work taking place. You will see it's primarily most of the patents between 2012 and 2019 come from China. The US then is obviously in the quantum computing, which is the software, the algorithms, the processing power, etc., that I mentioned at the start. And then you have Japan, Canada, South Korea, etc. But I just thought it might be interesting just to finish with this to show where the research from a geopolitical perspective is going. Thanks, Paul.
Thank you, Kieran. Again, that's a very good characterization there, and I think in terms of use cases, as many as possible and as varied as possible are really necessary here to really understand the promise and to let people see the parallels that might allow them to see how things might be adopted in their own sector or stream. So I see questions are coming in there on the Q&A, so please do address your questions there as you see them, and we will address them to the panel. But we'll move on to our next speaker now. Venkatesh Kannan is the Technical Program Manager at the Irish Centre for High-End Computing, the National Centre for High Performance Computing in Ireland. And Venkatesh is responsible for defining and implementing the technology vision, strategy and roadmap for the centre's activities. And high performance computing is seen as very much the model by which quantum computing is likely to be adopted. So there's quite a lot of insights and parallels there that will help us understand how the early stages of quantum computing will come about. But Venkatesh also represents ICHEC at a number of Irish and European programs, activities and projects. So he has a wide view across the entire sector. So Venkatesh is going to tell us about the skills development, pipelines, talent management, and also then the specific quantum computing programs that are going to be rolled out shortly. So Venkatesh, welcome.
Thank you very much, Paul, and good morning, everyone, for joining. So I believe Maeve and all of the speakers before, including Kieran, laid out the case of why we are actually looking into quantum computing and its adoption over time as a technology that might benefit businesses and different sectors. So, so starting from that point, the training program, the quantum programming certification course that we are looking at, is aimed at different kind of target audiences at enterprises. So it's just not the developers, engineers, and the solutions people, but also looking at the executives and technical managers and be able to position them as industry leaders to better understand where the technology is at, what its potential is going to be over time, and how it may impact both the business solutions, but also the market as a whole, so that they can strategize building capacity and their own investments and roadmaps in adopting this technology as it evolves. So the quantum programming certification course is pretty much a very customizable course that is going to, for example, position executives to assess the impact of the technology over time. So it's just not a one-off learning curve here. It needs the technology's evolution actually mandates that the decision makers periodically track the development of the technology and assess its maturity and strategize accordingly as it evolves and scales. And also for the technical managers from a more closer perspective to watch the evolution of the technology in more detail, and then decide on how and when the technology, the capabilities and skills can be built within organizations. And naturally, then that would permeate to the people that do the practical work on demonstrating the capabilities in the context of the business and the solutions and applications within their own sectors for the industry. So pretty much the program, as I said, or the course, as I said, is quite customizable going forward. In the first instance, for first half of next year, we will be targeting the delivery of the program or the course for the executives and technical managers. And as Maeve pointed out, in parallel with that, a more detailed course for the developers, engineers, or scientists is under preparation as well, which is likely to be launched later on next year. So a quick overview of the certification course. I wouldn't walk through all the nitty-gritty details. We'll be happy to discuss them. But in a broader sense, the course is structured in a way that any participant can define your own personal pathway through the modules and the technical content. So the content are broadly structured into themes, And the first theme, one of the themes is introducing the potentials and capabilities of quantum computing as a technology, but also opening the takers of these modules to what kind of activities are happening at a national, European, and international level, so that you can not just track the technology and its evolution, but also the programs, financial programs, strategic programs from the government, the European Commission, that would allow and finance your engagement as enterprise partners in adopting this technology and skills development. So that's also equally crucial. So in addition to just watching the technology, if you wanted to get on board, what support mechanisms do you have at the national and European scale? Then we kind of come into the more slightly technical themes, which is this one presents what are the different methodologies in which quantum computing technologies are developed, how do they look in practice, and this kind of gives anyone the capability to watch the technology's evolution over time and determine what key tipping points need to be achieved, what key milestones need to be achieved for the technology to be more practical and scalable in the coming years. And then there always needs to be, for the developers, the more technical people, to have a solid foundation in the required mathematics and computer science. So there are supposed to be a few concepts that need to be delivered, particularly focused on the developers and not necessarily for the executives and technical managers. So there are going to be modules that cover the fundamentals, and also then the broad portfolio of algorithmic methodologies and use cases that quantum computing can address. So Maeve and Kieran did definitely touch on some of them here, but then there needs to be a more structured introduction of the use cases and practical applications and the underlying algorithmic techniques that enable all of them over time. And then at the moment, there are a plethora of software development and programming tools that are being built by both the vendors, but also specialists from domains. So a structured way of presenting the software toolkits and programming environments that would also be covered as a part of the certification course. So naturally, as I mentioned, there are different pathways in which this course can be taken by anyone. For the executives and technical managers, particularly for the executives in the first instance, it's basically something that can be very much customized to the requirements of the takers, and the executives would primarily be focusing on the demystification of quantum computing so that one can understand how it sits alongside your classical technologies, ICT technologies and data analytics technologies that you use at currently. More importantly, what the quantum computing technology can do and cannot do for you, because there are so many different promises that are being made. So at any given point in time, it is important for the executives to clearly sift as to what the technology can deliver now and what needs to, how the technology needs to evolve over time for it to become more and more practical in different areas. And then the second module focuses on how quantum computing is going to sit alongside what are the developments happening both at a strategic and technical level to couple and integrate quantum computing within your current classical computing paradigms that we have now. For the technical managers, naturally, we would want to go a bit beyond that in presenting the background on how quantum computing systems are being realized and how they can be accessed at this stage, because there are different mechanisms in which one can gain access to quantum computing systems. They might be through cloud environments, they might be through partnerships with the developers of the technology for on-prem access. One can even download software emulators of quantum computing systems and its functionalities onto your personal laptop or for deployment on your workstation. So there are different mechanisms in which you can gain access, and all of these are going to be necessary key ingredients for the managers to have a roadmap and a watch list of what technologies are available currently and what key metrics and targets needs to be achieved over time so that they can track the technology's evolution. And naturally, the landscape of the software development support and the quantum algorithmic techniques would also be key ingredients for managers to basically do the technology watch and plan the capacity and skills development over time. And in terms of the duration, these modules would be delivered as, so to say, sessions, and each session is roughly half a day's worth. It's composed of a recorded or supported lecture. That would be a live tutorial session where it will be purely discussion driven that can be customized to the audience. And also there will be a practical hands-on session as a part of every session. So every session is composed of a lecture, a tutorial, and exercise worth around half a day. And for the executives, it can be again customized to either half a day or 1 day. For technical managers, we typically believe that to get the learning outcomes for maximum impact, around 8 to 10 sessions are going to be required to deliver that level of detail that will equip you there. In future, the developers version is a lot more in detail, so it builds on what technical managers learn. But as you see, the bits in orange and green are going to be the added depth, so to say, of the methodology. So the orange bits are your fundamentals of quantum computing and the required mathematics that equip you to learn the algorithms in more detail and demonstrate the use cases. And then the further green bits at the bottom are basically a bit more detailed introduction into the algorithmic techniques and particularly the use cases. And it's through these kind of quantum computing concepts and algorithmics that one can select to learn the programming toolkits that are one, better suited for certain use cases, and two, that are going to be of interest to your organization. So it depends particularly up to each enterprise or the attendee, whether you want to learn a broad range of software development toolkits and algorithmic techniques, or you're more focused on use cases that are particularly of interest to your organization. So this can pretty much be customized, and over time, the modules will be developed so that it's a lot richer. And optionally, what we also target is throughout the period of a developer version, a participant might be interested in doing a practical mini project, so to say, which can be, again, the scope of which can be customized and discussed with ICHEC and defined. And this project would then be done through the entire duration of the course. Again, depending on which pathway one might take as a developer, the course might last anywhere between 24 to 32 sessions, each session worth roughly half a day. So that is basically the envisioned trajectory of developing this course. As we said, in the first instance, first half of next year, we plan to deliver the executive and technical managers version, and then the developers version is under preparation as well, and we'll be happy to share more details going forward. Thank you.
Thank you very much, Venkatesh. It's good to see that there's a comprehensive program there, and there are multiple options. Just with regard to our polls, unfortunately, we had a bit of a problem with them earlier, so we think we have it fixed now. So Sarah, if we could ask question 1 again in the revised poll, that would be good. But I'm going to invite Stephen Flinter, Vice President of Artificial Intelligence and Machine Learning with Mastercard Labs, to come on now. He's going to give us a little bit of an update around the activities of the Industry Advisory Board. Stephen, welcome.
Yeah, hi, thanks, Paul, and good morning. Firstly, I guess I want to congratulate ICHEC and ICT Skillnet for kind of developing this program. You know, I would agree with all the previous speakers. It's incredibly timely and certainly very relevant to where we're at and what's going on in the industry at the moment. For those of you who are not familiar with Mastercard and with our R&D activities here in Ireland, we have 700 plus technologists located in Sandyford. We are growing that number quite rapidly and have plans to get to about 1,500 over the next number of years. And it's also the global headquarters of Mastercard R&D's activities, and it's our largest R&D lab based here in Dublin. So we're very much kind of supportive of the program as it's been developed. We certainly anticipate that we will put a number of people both on the executive track as well as the technology track, as Venkatesh has laid out, through the program, and this is going to be one of our hubs for quantum related technology development and innovation and research. So certainly very excited to see this program get off the ground, and we will certainly be great supporters of it. And I think I probably speak for a lot of the members of the Industry Advisory Board, where we have been kind of working with ICHEC, with ICT Skillnet, to essentially provide guidance around what are the things that we in industry see as being relevant and important for us and for our employees, both current and future, for a program like this. So this is very much driven and guided by the needs that we see. And we hope once it comes to fruition and gets off the ground that we will start to see the skills come through in our own people that this program promises. So overall, I think very, very supportive and very much looking forward to getting this program started in the new year. So thanks for that, and back to you, Paul.
Great, Steve. Thank you very much. And again, it's great to see that level of support and involvement and again, activity on the ground here in Ireland. So thank you very much for that. So we're going to move into our panel session now. So I'll ask all of our speakers to come on mic and camera. And just to add that Peter Woods, Public Sector Liaison and Business Development Manager at ICHEC, is joining us as well. So I see there's questions coming in there already, and we are a little bit over in terms of time. So I think we'll just jump straight into the panel questions that have come in there on the Q&A section. So there's a question there: what quantum computing hardware is being used to implement the examples cited? So I think that's a very relevant question, because it kind of captures a couple of elements of the fact that as Maeve pointed out, the experience around AI has shown the level of preparation that's necessary to adopt something like quantum computing. So it's a strange situation that so much activity is happening when the actual hardware is still very much at lab stage. So Maeve, do you want to maybe take that one first in terms of what hardware is actually around at the moment, and what's its kind of development path towards practical implementation?
Yeah, sure. In terms of the list that I showed on the screen, I mean, there was different hardware used on and different examples. Like, say, for example, the Biogen one I was talking about, we worked with 1QBit, which is a software provider, on IBM hardware. So that one was IBM. The Volkswagen one, which was about the traffic optimization, they actually worked with D-Wave, a quantum computer from D-Wave. And then like the one on batteries with Daimler, that was again on an IBM computer. So you know, there's a variety around at the moment. It's interesting. I'm doing a project at the moment with Venkatesh's team, and we're in the second year of it. And the first year was about like figuring out on a simulated quantum computer what we wanted to do, but now we're getting to use hardware, and we've actually switched hardware provider that we're probably going to use in the last couple of months, just because partly because the way the market goes, you know, somebody jumps ahead, or you know, someone becomes more relevant. So to your point, Paul, there isn't one provider at the moment that you could say you definitely want to go to. It's an evolving landscape all the time. So I think there's always, you know, you need to check the landscape when you decide, but then you sort of need to monitor it on an ongoing basis. And I think from the point of view of using, say, a cloud quantum computer, you want to build your solutions so they're plug and play, so you can plug into a different one if you need to. And that's actually something we're working on in the project with Venkatesh, to make it agnostic to the actual cloud provider that we use.
Very good. Venkatesh, do you want to comment on that quickly?
I completely agree. So as Maeve pointed out, we have access to both prototype hardware, but also more importantly, the power comes when anyone is able to download a software emulator onto their laptop, even though it's going to be limited capacity, and start playing around with the examples that are provided and better understood. So it's always a good place when you have quick access to a system and don't have to wait for something. So the software emulators there are the first step for many developers to get on board. But eventually, as Maeve pointed out, it's important to understand the differences when we start working with hardware. For this particular training program, though, we also realize that it's going to be a little bit learning curve to put anyone on cloud systems immediately. So we are building a quantum learning platform, which has already been funded for by the by the government. So the quantum learning platform will provide a more comprehensive environment through the national service from ICHEC for users that are going through this training course, but also doing research. And if you wanted just direct access to an environment where you have a portfolio of software libraries, then we are actually setting it up in preparation for this course's delivery. So both for people that are enrolled in this course, but also from a national services point of view from ICHEC, we will be offering this platform environment to all users. So it's not going to be a hardware quantum system, but it's a software emulated one through which eventually we'll provide access to European hardware systems as well over time.
Very good. Well, there was another question there in terms of the minimum knowledge or experience level, I suppose, for the course aimed at the technical managers. So if you could maybe kind of recap around that, Venkatesh, and you know, what would an ideal candidate be, I suppose, coming to that tech manager course?
Right. So we do not expect the technical managers to immediately go back and start developing algorithms or implementing software. So we are very conscious that the learning curve can be quite steep and it can be a rabbit hole. So the minimum technical requirement or background we would prescribe for technical managers version is to have an understanding of ICT and software development so that one can come on board and understand how a software development workflow looks like, and then look at what are the physics and mathematical skills background that one needs to build within the organization going forward for looking at algorithms and their implementation. So the technical managers, an ICT background would be great. Some awareness of software development pipeline would be great, but we don't expect anything more than that in terms of math or physics background. In terms of the trajectory, we expect the technical managers to go back and basically define with their team, both executives and developers, as to these are probably the first use cases that we can start looking at. These are the kind of algorithms that we can start looking at, and then bring on board their developers and have them skill up over time. So the technical managers, we expect them to drive that skill development and use case development within their organization after the course.
Okay. Well, there was another important question there just in terms of funding and supports, specifically in terms of the EU, but also, you know, what might be available nationally. So does anyone want to comment on that?
So there is, I just responded there. So the EU in 2018 launched Quantum Flagship Program, which is 1 billion investment over 10 years. And I also just included in the chat there a link to it as well, if anyone's interested in looking at it. I think there's obviously various countries. I think Germany is probably one of the biggest countries investing in it. I think in the last 6 months or so, did Angela Merkel invest or confirm that 2 billion was going to be invested in it from a Germany perspective? Other countries, I don't have that detail.
Okay, well, still, it's good to see the scale of investment that's going into it, and I suppose
it's significant.
It shows a context for what we need to do nationally around this as well. Venkatesh, do you want to?
Yeah, and I was just going to say that flagship, I mean, yeah, it was launched in 2018, like Kieran was saying. Accenture was one of the founders of it, but it's I think third most biggest funding that the European Commission did of any sort of innovation and research sort of collaboration. It's over 10 years, and they put in the third largest amount of money into that of any that they've done. So it sort of shows it's being taken seriously. And there's like, at the moment, there's a funding call for a Digital Europe program that has quantum elements to it. So there's actually quite a lot happening in Europe. And Germany is quite strong. They've got a Planck consortium, which is looking at AI and quantum, which, you know, mixing the two together, which again is probably one of the areas that'll come to commercial value quickest. So they've got a whole consortium looking at that. But we're seeing, I think there's a consortium now starting up in the Nordics. I don't have the name, but I can find it afterwards. But we're seeing, even like over the last 12, 18 months, a lot of activity across Europe in this.
Great. Okay. Well, I suppose public sector is going to be one of the areas that benefits most, as Maeve, you pointed out, the things like scheduling, logistics, and the classic salesman program. So I would imagine there's quite a number of applications there for things like public services and organizing resources and that sort of thing. So what's the government interest here or engagement so far around those?
Is that to me?
Well, to whoever might have an insight around that.
Well, just with respect to what state agencies are saying, I think what you've just seen recently is the IDA believing that this is now moving to a tipping point. They're talking about sectors, and it's reflected in the poll: financial services, and particularly financial services, because the problems tend to be well defined. The use cases are strong. They've also mentioned drug discovery and the whole area of production performance within the pharma sector and life sciences. But you're right, government is a big area where quantum could be applied in terms of logistical planning for service delivery. So we will see. But I think the point that the IDA were making is we've now moved to a point where these are now practical, pragmatic problems that can be solved with quantum. And therefore, we should be skilling up to be able to get the types of expertise in place. One thing I would just like to say, with respect to the technical manager and the executives, what we're doing here, developing pathways to inform the development of that capability when they go back, to be able to ask the right type of questions, to put the skills in place, to put the strategy in place. Kieran mentioned it, Maeve mentioned it, the strategic planning, to be able to put in place the types of expertise now at this stage and the use cases and develop the prototypes. So that's the stage we're at, is to start to prove what this technology can do, as much within public sector as within the commercial sector.
Okay, Venkatesh, I see you have your hand up there, so just 1 second. Sarah, if we could just run our second poll, because we're just about up on time, and we'll let people vote on that. So Venkatesh, do you want to come in there?
Sure. I wanted to share something which kind of ties both questions together on public, on state investment and European activities. So there's a significant trajectory of co-funded efforts in the European Union, which is the Commission and the member states co-fund technology development and research activities as a whole as well. So the quantum learning platform was indeed funded by the Irish government, and as Anthony pointed out, the state agencies are kind of incrementally building up as well. And the government, the Irish government, has also co-funded a number of quantum computing related projects with the Commission, in which Ireland is a partner, particularly through ICHEC. And those kind of activities also contribute to the state's investment, and they are towards developing these quantum computing platforms, providing their access to national users as well. So there are these projects that are co-funded significantly by the state as well.
Great. Okay. Well, thank you, everybody. I see people have voted on that poll, so that's useful information to help guide people as well.
Well, just there was a question there about when this hopes to be launched. Q1 of next year, we hope to get this operational and off the ground, and to get the pathways active.
Very good, very good. And just a reminder that ICTskillnet.ie will have information around this as well, so you can keep an eye on that, as Anthony said there, for Q1 next year. Okay, well, listen, we're just slightly over, but not too bad. So hopefully that's not delayed people too much. But thank you to all of our speakers this morning. I think that's given us a good overview of where we are as a country, really, and what's necessary for developing that talent pipeline. And as Kieran pointed out, we have the record in this country of being able to develop those skills and to take advantage of these developments. So hopefully we'll be well placed with all of this groundwork in place to ride that wave. So thank you very much to Kieran, Maeve and Venkatesh. Thanks to Anthony and Peter for joining the panel as well, Steve for the update on Mastercard Lab's activities, and thank you all for joining us this morning and for all the questions to the panel. So hopefully this has been useful for you, and thank you again to ICHEC and ICT Skillnet for hosting us this morning. And